Hi there and welcome. My name is Michael Kentenich and I'm a Microsoft Technical Trainer. In this video, you will learn how to turn data into action with Azure Application Insights. You are a software developer working diligently on your latest project. Your application is up and running, but you're left wondering, how are users interacting with it? Are there any bottlenecks? Is performance optimal? And most importantly, how can you enhance the user experience? That's where Azure Application Insights swoops in like a superhero. In this video, I will explain how Application Insights works and how it collects events and metrics. I will show you how to instrument an application for monitoring, perform availability tests, and use the application map to help you monitor performance and troubleshoot issues. Azure Application Insights is a part of Azure Monitor, and it's great at application performance management for web applications that are live. Application Insights offers many experiences to improve the performance, reliability, and quality of your applications. You need to instrument your application to enable Application Insights. And besides collecting metrics and application telemetry data, which shows how your app is performing and operating, Application Insights can also collect and store trace logging data from your application. Application Insights monitors a lot of interesting data points that will help you to understand the performance of your apps better. Not only does it allow you to check how long dependency calls take and what exceptions are thrown, but also details about what individual users experience while working with your web app. This is a list of different features and components, but I'm going to show you this live with an example in a demo. In this video, we will explore Application Insight a bit more so that you understand what it is used for and what you can do with it. What we're looking at here right now is in the Azure portal, a resource of the type Application Insights. That is a resource that is created automatically when you enable Application Insights for an app service. And it is used to collect telemetry data and other information on how that application is utilized, because it can be used to inject the libraries into your application. So we'll send telemetry data to this resource. What we're using here for this is a demo application that Microsoft is using. So we look at a specific retail website as part of the Contoso Hotels tenant. And what we're looking at right now is the overview. So we see a few information here, including the connection string and the instrumentation key. And what I want to show you is what you can learn with Application Insights about the utilization and the performance of your application. So as a normal resource, it has also these predefined tiles on the overview page, but this is not really that interesting. So a really cool feature would be to first see what is going on right now, live, in real time, because this is not real time. This is always a few minutes off, but we can use this investigate section here and then log into live metrics, where we will create a session that will then show us live metrics. So you can then see what is really going on right now. So whenever there's a request coming in, and there should be always coming a request from somewhere in the world right now, as you can see on the right-hand side, a lot of different requests coming in, different trace logs appearing as well. But there's some requests where people either automation or people are actually doing some failing requests, and we see that what's going on. So in this live metrics, we see incoming requests, outgoing requests, overall health, where we look at the memory that is committed or the CPU usage, exception rate, and so on. So it looks not too bad. Also very interesting, sometimes at the bottom here, you can see that right now there's only one instance working with this, or it's not one, it's one instance, it's just spin up for this particular environment, which means there's not really a lot going on right now. It would automatically spin up when there would be more, but you can tell it's not doing that much, so CPU is quite low. So that's live metrics. But of course, we have a few more things. So on the investigate part, and that is what I want to show you now, is first application map. Application maps, creates a map with all the different components of your application where you have used that instrumentation mechanism. So if I zoom in here a bit, and it takes a few moments to load that. So we have a few application instances like the Fabricam app or the retail app, that what I'm looking at right now. And these different application instances use other resources like an Azure Queue, or they're connected through a connection string to a database, an Azure Blob Container, and a table. And you can see that not only does it map out these individual resources, because it understands that there are requests being made to these. Without these resources like the blob containers or the storage account being instrumented themselves, it just realizes that, oh, there are some requests going from that application into these resources. So we are tracking the dependency calls. How often does it happen? How long does it take? And it is automatically creating a baseline for these kinds of requests. Then you can tell that there are some links on here. So I see that my application right now is mostly green, but there is some red part here that tells me there's some problems going on. So I could go and just click on this, and on the right hand side I can see some predefined tiles that might not always look exactly like this and come in this order. It is putting some intelligence on it and say, okay, we have quite a number of failing requests. Then I will provide you with this tile, and you can tell that there are some different requests here that are made that with a count next to it, so I can look into this if I want to. Or maybe we have some questions or some investigation necessary about slow requests. So I can see here which are the ones that take the longest time. So I can go and investigate performance and so on. There are multiple tiles here, but the number, or let's say the actual tiles that you see here, might differ from whatever is going on right now with the application. So obviously, failures is probably what's causing that red part here. So I might want to go and investigate this further. Now, when you click this button, what it will do is it will basically just switch to this view here. So you can do this directly, but all these individual buttons are there to get you to the respective areas where you can see more information about what's going on. So that's something that's really nice and easy. So let's do this. Now I'm at this failure overview, and we see a lot of things. We have different tabs for operations, dependencies, exceptions, and roles. That is all organized in time slices. I can even see either from a browser perspective or from a server perspective, depending on which view is what I want to have at that point. And if I see that there's, let's say there's a certain error like this one here where I have multiple failures, I could zoom in. And you can tell that on the right hand side, it's automatically adjusting to show exactly what was going on in this specific time frame. You can change this at any point in time. You can select the overall operation or limit this down to a specific operation, and you can tell that everything around this is all dynamic, so I can see individual adjustments in here. So yeah, so obviously there are a few 500 error codes in here, or status codes, so I can now do a couple of things. I can look at the samples that are coming from that overall filtering right now, or I can click into this error message, and then on the right hand side I can see those sample queries where I say, okay, when someone is using the customer's detail request, that returns a 500. So I might know already what that means, and I can go and test this out a bit more, but I can even go one level further and say, let's look at the end-to-end transaction details. This will show you completely the flow where this is either not being transported further, or we try to reach out the database and we cannot find a certain table that is referenced here and so on. But in this scenario here, I can have a look and see what is the actual exception that is thrown in here. And I can have here the call stack information that usually, I mean, hopefully you're not really showing this to your customers, but this is what we will want to see in a test environment. Now, obviously, this is just a way of getting you more information as a developer to troubleshoot this, to triage this completely with the team, but it might not be sufficient enough. So there's some other links that you could use, some related items where I could say, yeah, show me what happened before and after this exception in user flows. User flows is part of application insights that shows you what happens, how did a specific user navigate through your site, and how did they navigate through this. You could also see all the telemetry from that user session, or you could see all the available telemetry data before and after of this specific event, and that will help you drill down or limit this to a specific time frame so you understand where to look next. Now, obviously, this is all based on logs too, so it's not just a visual representation. It all has logs information. So what happens when I click one of those, I get almost already a logging view where I can see different elements and what happened here, where it traces, where it requests, and so on. And in here, these are already specific snippets. Let's say I want to see one of those in here, and I can always go back and forth between these different views and understand more what is going on. Also, if I open any of these elements, I can go and have a look at the logging view, which, let me just show you this example in here. So this is another view. This is all based on logs, and you can drill into the logs itself, where we use Log Analytics Workspace to collect all the data. All the visuals that you just saw are based on that log information, and now I can really see the actual raw data. It's already getting you that KQL, the custom query language query in here, that gets you the individual pieces. So you can drill into this and see what exactly was going on and get the most information that you need at that point in time. Now, the same that we can do for failures, we can go back here and have a look at availability, similar things, right? But with a focus on availability. So at some point there was something going on here where it looks like there was a service dropped or lots of different failed availability tests or availability in general. I can come up with an availability test saying, hey, I want you to reach out to a certain resource and check if it's available or not. If not, I will see this represented in here. So there is a customer check in here that was set up that allows us here to check if a certain virtual machine or an instance on a cluster is not available. I can go into this configuration from here as well. And I have the same thing for performance. Now, the UI is similar, but it shows different information, obviously. But you can drill down to this and look at performance-related issues in the same way. It has a lot more to offer. So what I encourage you to do is take, if you already have application insights running in your environments, use an application or a solution that you're familiar with. Look at the data that it is presenting to you so that you can really understand what it gives you, what is the value that it adds to your troubleshooting or even proactive improvement jobs. Another part that I want to talk about real quick is smart detection, because that's something super cool where we can enable certain smart detection rules that will, over time, when I said before, it's taking a baseline automatically. So it will understand what is the average or the typical load time for a certain page, or what is the typical server response time, what is the typical time for dependency call. And if these times at any point starting to slow down, or there's some degradation in the server response time or the service availability, you can enable these smart rules and then send an email to a specific email address or to the owner of that resource, so to get them that really first-hand information saying, hey, there's something unusual going on, you should look into this. Some of those are still in preview, which means also that we're increasing the smart detection settings over time. So that is a really cool feature that you should definitely set up and enable and learn from this. And then you can tell if there are any smart detection rules showed right now. I don't have anything here to show right now, but that is a good sign. So everything behaves like it usually does. So yeah, play around with application insights, learn more about your applications and how they perform, and maybe you'll find a few things that you can improve. Log-based metrics and pre-aggregated metrics are two ways of storing and analyzing telemetry data in Azure Application Insights. What does your team care more about? In-depth analysis, troubleshooting, and identifying trends or anomalies? Do developers, operation teams, and analysts require detailed insights from raw data? Then log-based metrics are what you need. Or does your team care more about faster query performance and reduced resource utilization? Are teams looking for quicker access to essential metrics for monitoring and reporting? Then pre-aggregated metrics are what you need. Log-based metrics store all collected events, while pre-aggregated metrics are stored as time series data with only key dimensions. Although log-based metrics provide complete sets of events and may be more useful for applications generating a large volume of telemetry, pre-aggregated metrics only provide a subset of metrics and may be more useful for smaller telemetry volumes. If you want to get application insights data, then you need to instrument your application. There are two ways of doing so: auto instrumentation and manual instrumentation. Auto instrumentation allows you to enable application monitoring with application insights without changing your code. Manual instrumentation is required when auto instrumentation is not available for the framework or language you use. But don't worry, it's really easy and the steps are fully documented. I will walk you through these steps in the next demo. In this video, I want to show you how to instrument local .NET application to send telemetry data to an application insights object. So first, I will create a new application insights object in my Contoso app resource group. I will give it a name. So let's say we use this now for Contoso. Just use a unique name. I will use workspace base, which means that it will store all the logs in an existing or a new log analytics workspace. So what I would prefer for you to do, or in general in real life, don't use the general created ones in here, but create one first, give it a name that is meaningful to you, like this is my solution, Contoso app, whatever, and then let it select you. Because at this point you cannot create a new one, it will just create one for you. For my purpose now that's good, but yeah, keep that in mind. So now I will create this. Now this resource is going to be the point where all the data will be collected from my application. And for me to be able to use this, I will need that instrumentation key here. So I will copy this for later, or we can just grab it when we want. Right now, there's nothing sending any information to this. So that's the first part. What I will do next is go to Visual Studio Code. I have an empty directory, so there's nothing in there right now. And I would like to start building a local application. So we will create a new web API. Let me just check. Yeah, that's actually exactly what I want. So we will create, based on a template, a web API in this folder. We will give it the name Simple API, and it's based on the .NET 8.0 framework. So I will let it create the files for this. And since I want to use the libraries instead of reinventing the wheel and using just REST APIs, what I will do is here, I will paste in a bunch of different packages that will be added. So I will show you which packages these are all so that you can have a look. But of course, the way I know what to add is just because I looked at the documentation. So that's the last one to be added here. And now we should have everything in here. And let me just show you this for a moment so that you can see all the packages. So we use the Microsoft Application Insights package. ASP.NET is the specific one for this framework. Performance Counter Collector is important later on for live metrics. And then also there's a specific profiler for ASP.NET Core. Okay, these are the packages that I just added. And now I have already an application in place, the API, but we need to do some changes before we go any further. The first change that we need to implement is that we need to enable the profiler by registering it along with the application insights into the service collection. So it starts collecting information. Then the rest of this code is all for that API. I will show you this in a moment. And for our use case in here, I will remove this because this is just forcing the application to use HTTPS, but we don't want that for now. And other than this, I will let the app be as it is. So what I will do later on, I will use this API weather forecast, and then we should see some data. And I will show you this, but this is actually already enough from the code perspective. What I need to do as well is in the app settings file, where we have the configuration, I need to add here a section for application insight. So let me just add this to the bottom here, where we use application insights, and I need to provide the connection string. Connection string that I have, I had it copied, but now it's not. So I will use the connection string. So just one quick side note. There is, right now you have both an instrumentation key and a connection string that includes that instrumentation key. That instrumentation key at some point will go away. So we will only have the connection string left. So start using the connection string already to get already future-proof at that point in time. So that's why I decided to use this option. So I have this information in here. And this is how the app with that registering of the profile and all of that now knows where to send that information to. And this is everything I need to do. So now let's go back and open up the terminal. So first of all, let's quickly check that this actually builds. And I didn't make any mistake. Looks like, okay, let me see, because I think, okay, let me use a more advanced version of this, and then we publish then an artifact and let it build at the same time, so we see if that works okay. Now that it has been built, let's run it. Okay, so now application is running. So it tells me here that it's listening on this local port, so I will use this, copy over to my browser. And there's this weather forecast API that should now send me just some random data. And you can see that if I refresh this a couple of times, it just comes back with some random data. It's always the same thing. There's not really the actual data behind it, but that's my application running right now. Now, what we should be able to see if we now lay this side by side, and it might take some time for this to actually work, but I should see data coming into this. I mean, it already has changed here that it is not just showing this placeholder again, but this will take a few minutes for this here to show anything. What I could do is let's go into live metrics and connect directly to my application. And yes, it's collecting to the local application running on my machine. It's not running on Azure. So nothing goes on right now. But let's just refresh this a couple of times. So we will do a couple of requests. So I should see on the top left a few incoming requests. If I click a little bit more, we could see that there are some spikes coming in. So this is the request data that comes in. And now that I stop doing this, it will be flat again and saying, I'm not doing anything in here. So that is just how easy it is to get a local project with the manual instrumentation that I just did. And of course, there are a lot more options. You can configure the different collection rules. You can decide what should be transferred or not to the application insights object to make all this information that we have seen in the other demo before available. And for, as I said, most platforms, you don't even have to go that far. It can do the changes for you automatically if you use Java or .NET and some others as well. And over time, sure, more will do this. And yeah, that is like a super short demo on how to instrument a local .NET application for using application insights. In this video, I have described how Application Insights works and how it collects events and metrics. And we looked at how to instrument an application for monitoring, perform availability tests, and use Application Map to help you monitor performance and troubleshoot issues. You have now unlocked the power of Application Insights for monitoring and enhancing the performance of your applications. By using its tools and capabilities, you can gain valuable insights into application behavior and optimize performance and stability. With Application Insights, empower your team to deliver exceptional user experiences and drive continuous improvement in your applications. Thanks for watching. Keep on learning.